yesterday we talked about how to predict the products of a chemical reaction. Okay, we said that the steps for doing that was to first write it out, as much of it as we had. Okay, so that would be like question number 7 here, which I just wanted to walk through. Okay, so I have written out the reactants, which is all I have, okay, in formula form. So that's the first part. Now that I have the reactants, what can I tell? What do I know about the reaction once I've written those? I need to know, I can tell, and I need to know what kind of reaction it is. Okay, this reaction starts out with 2 ionic compounds, which means it is a double replacement reaction. All right, so now that I know that, then I either have to go back to my notes or I know in my head that in a double replacement reaction, the metals switch places. Okay, they're going to switch partners, and I'm going to end up with 2 different ionic compounds on the other side. So who is calcium going to end up with over here? With who? With bromine. Okay, and that means that iron has to end up with chlorine. Effectively, this is all I do. Okay, that will predict the products for a double replacement reaction. They're actually pretty easy to predict. All you have to do is swap the metals. Okay, so we will have then iron with chlorine, calcium with bromine. Okay, now those are both ionic compounds, so what do I need to do with them? I have to do the thing with the charges, the swap and drop. Okay, always have to do that when I make a new ionic compound. So what I have to do first is figure out, okay, on this side, what charge did iron have? Okay, on this side, iron was a +3 because bromines are -1s and there were 3 of them. There's only 1 iron here, so it had to be a +3. Okay, so this is a +3. So when I drop and swap, I'll have FeCl3. All right, and then for this compound here, calcium's always a 2+, bromine's always a 1-. All right, so we're looking at CaBr2. So I figured out what kind of reaction it was. I made the partners, okay, or the new compounds, and then I dropped and swapped them. Okay, if it wasn't a double replacement reaction, I would drop and swap anything that was ionic and look for special elements that might need little numbers beside them. All right, last thing I have to do is balance this whole reaction. All right, on this side I have 3 chlorines, and on this side I have 2. How am I going to make that balance? 6, yeah, I go with the lowest common multiple. Okay, so on this side, I'm going to put a 3 here to give me 6. Okay, and on this side, I'm going to put a 2 here to give me 6 chlorines. So now my chlorines are balanced, but obviously I've put in 2 numbers that affect other elements. This 3 also affects the calcium, so I need to go over here and make sure that I have 3 calcium. Okay, when I do that, it gives me 6 bromines. So I've got to come back over here and make sure that I have 6 bromines by putting what here? A 2. Okay, when I do that, it gives me 2 irons, and I have 2 irons over there. Okay, so I'm good. All right, so that's the prediction process. That's what we want to work on and practice today. Okay, it requires us to be very familiar with our reaction types, and it requires us to be able to think kind of critically, all right, when we're going through it. All right, I would like you guys to write down, let's say, 5 through 8 for right now, and give them a try. Okay, predict the products and balance the reactions. All right, so for our first one here, we've got beryllium reacting with iodine, which would be what kind of a reaction? It's synthesis. Okay, these are 2 elements. They're going to react and form a single compound. Okay, that single compound is going to be beryllium iodide. Okay, now that's the pairing, but beryllium has a +2 charge, okay, and iodine has a -1 charge, so we're going to be looking at Bei2 as our product, okay, and that means that the reaction is also already balanced. Okay, questions on number 5? Okay, so guys, I'm going to kind of harp on this. I'm not trying to make you feel like you're slow, okay, but I'm going to go through each of those steps that I've talked about each and every time I do one of these. All right, so for question number 6, I've got an element, in this case it's a metal, potassium, reacting with iron 2 oxide, which is an ionic compound. Okay, metal, non-metal. So what kind of reaction sets up with an element reacting with an ionic compound? single replacement. Okay, now with single replacement reactions, I still want to do some swapping. In all replacement reactions, I want to swap something. I have to decide what's trading places. Okay, here's how I decide that. The thing that's by itself will change places with the part of the ionic compound that it is alike. Okay, so this is a metal, so it's going to swap out the iron. Okay, it has to replace the thing it's like. All right, so it's got to replace this metal. All right, so in this case, we are kind of swapping the metals in this case. Had this been nitrogen, then it would have swapped out the oxygen. All right, everyone kind of follow me on that? Okay, so we're going to swap out what we're like. That means Fe ends up by itself, and potassium ends up with oxygen. All right, replacement reactions, single replacement reactions, are the ones that have the most things to look for. You're going to produce an element, which means it could be a special element and require a small number, and you're going to produce an ionic compound that needs to be dropped and swapped. All right, so you have to check for both. Iron's a metal. There's no special metals, so we don't have to worry about that. Okay, well, actually there is hydrogen, but okay, this isn't one of them. So, okay, it doesn't need a small number. It's good. Okay, this is an ionic compound that needs to be dropped and swapped. Oxygen's a -2, potassium's a +1. So we got K2O. Okay, for that. Now I've got to balance the whole reaction. Okay, the only thing that's out of balance is potassium, and it just needs a 2. Now everything else works. Okay, questions on that one? Right. Okay, for number 7, I've got copper 2 sulfate, an ionic compound, metal and polyatomic ion, okay, reacting with magnesium chloride, which is also an ionic compound, metal, non-metal. Okay, so what kind of reaction is that? Carla, what kind of reaction is that? There's 2 ionic compounds. Starts with D. Double. Okay, so this is a double replacement reaction. In a double replacement reaction, I just swap the metals. That's all I have to do. Okay, so that means that magnesium will end up with sulfate, and copper will end up with chlorine. Okay, I produced 2 ionic compounds. What do I have to do with them? I have to drop and swap. Okay, I have to make sure I get the numbers right. This is a 2+, this is a 2-, so that compound is fine the way it's written. Okay, copper can be a 1 or a 2. What is it on this side? Sulfate's always a -2. There's only 1 copper, so it must be +2. All right, so then I know over here, copper's also a +2. Chlorine's a -1, so when I drop and swap, I get CuCl2. Now I've dropped and swapped everything. Now I go back and balance. Balance is always last because I need to make sure I have all the small numbers right before I start trying to put in coefficients. All right, so I got 2 chlorines, 2 chlorines, 1 magnesium, 1 magnesium, 1 sulfate, 1 sulfate, 1 copper, 1 copper. It's already balanced. Okay, so I don't have to do anything with it. Okay, for number 8, what kind of reaction is that? That is a combustion reaction. That is butane reacting with oxygen. That's the reaction that happens in a lighter. Okay, so if you use a lighter, okay, this is the reaction that happens in a lighter. Okay, so C4H10, okay, reacts with oxygen. What are always the products of a combustion reaction? CO2 and water. There's nothing to figure out here. That's just a memorization thing. Okay, I just memorized that always the products of a combustion reaction are carbon dioxide and water. Okay, there are 2 special rules. Balance alphabetically, rule of 2. Do I need them both? Yes, I do. 4 is an even number. All right, so I start with a 2. 2 times 4 is 8. So now I have 8 carbons and my carbons are balanced. 2 times 10 is 20 hydrogens. Over here, 10 times 2 is 20 hydrogens. Now my hydrogens are balanced. Okay, now I've got to balance the oxygens. I have 8 times 2 is 16 oxygens in the carbon dioxide. I have another 10 oxygens in the water for a total of 26. 13 times 2 is 26. Okay, questions on 8. So with combustion reactions, the prediction part is easy. The balancing part we have to play around with a little bit. All right, a couple more here that I want you guys to try. Try 9 and 10, okay, and then we'll go over those. All right, so in question number 9, I've got rubidium phosphide And that's my only reactant. What's the only reaction we've gone over where there's only one reactant? Decomposition reaction. Okay, so in a decomposition reaction, I'm going to end up with the two parts of the compound now separated. Okay, simple decomposition reactions are another one where we've got to look at our products carefully so that we don't miss any special elements, because we definitely have one here, okay, that is very special, and that's phosphorus. It always comes as a 4. Okay, so anytime you have a reaction that produces an element as a product, make sure you check your periodic table to make sure it doesn't need a small number beside it. Okay, all right, so now that I've got those done, now I can balance the whole reaction. Okay, now on this side here, I've got 3 rubidium, but I've got 1 phosphorus. Which one should I do first, rubidium or phosphorus? Phosphorus. I should do phosphorus first because generally going with the largest number works better. All right, so if I put a 4 here, that balances my phosphorus, but it gives me how many rubidium? 12. And now it's balanced. Okay, that making some sense? It's going to take some practice, and we've got lots of time for that. Okay, we got today, we got tomorrow. Okay, Thursday we'll be doing our lab. That lab report won't be due till the next week, so we'll have lots of time to get good at predicting the products of a chemical reaction before it's going to be for marks or anything like that. Okay, all right, I'm going to give you about a 3-minute break here, and then we're going to get back to work on more predicting stuff because we got to obviously practice a bit of that. Okay, so a 3-minute break. Okay, if you need to go to the bathroom, go to the bathroom, check your snaps, whatever. All right, so the first 2 are the examples I'm talking about. These ones have more than one possible answer depending on how you write water. Okay, if I write this first one as potassium is added to water, and I write it like this as H2O, okay, this is a single replacement reaction, sort of, okay, is what goes on. It's a very violent reaction, okay. Anything in group 1, okay, like sodium, potassium, rubidium, cesium, all of those, okay, you throw them in water and they just explode, okay. Well, no, because we're not allowed to have it anymore. Yeah. I remember when I was in high school, like my chem teacher took like a chunk of sodium that was probably about that big, okay, and he threw it into a garbage can, like a big one, like one of the big ones, and chucked it in there, and the garbage can just, that was it, it was gone, just destroyed it. Okay, it was a violent explosion. You can see why we're not allowed to do that. Okay, it also creates a very basic solution afterwards, so any of the spray, if it got on you, is corrosive. So, and there's also, the whole energetic explosion thing, okay, which is also, kind of dangerous. Okay. I mean, guys, I come from a totally different generation. Safety was not a concern. Like we break a thermometer, we'd play with the mercury. Okay, ooh, this stuff's cool. It's poisonous. It absorbs through your skin. We didn't know that. Probably why we're all messed up. Okay. All right. So I could write it this way as potassium reacts with water, but then I'll get my products to be this: hydrogen gas, explosive. Okay, and that's what's going to get produced, okay, plus potassium oxide, okay, that's one way for me to write it, and it is one of the things that happens when that reaction occurs, okay, this is the part here that's generally explosive, that whole Hindenburg blowing up thing, okay, that big Zeppelin that exploded full of hydrogen gas, okay. The other way I could write this could be, I could say potassium is added to water, and I could write it as HOH. If I write it that way, then this ends up being H2 plus KOH, which is also one of the things that happens, okay, in this reaction. This is the more common thing that happens, right? But then when I do this, I've got to rebalance, okay, in order to make it work. So there's actually 2 correct answers, depending on the way you write it, okay? The second one I wrote is the one that really happens for the most part, okay? Produces a basic solution afterwards, which could be corrosive, okay? Hydrogen gas, which is explosive, okay? And that could be bad, all right? Calcium also added to water, same idea, okay? I could have calcium plus H2O and get H2 plus CaO, or I could get calcium plus HOH, okay, and end up with H2, okay, plus CaOH, 2, okay, and then I would need a 2 here in order to make that work. Either one of those would be considered a correct answer, depending on how you wrote water. Okay. All right. Any other ones that are giving us issues? How many people are like, let's say, to at least number 5? Okay. All right. Let's keep working on that here then till the bell goes, which isn't long.